In this lesson, we're going to continue on talking about ways we can prove triangles are congruent without using all six sides and all six angles in the two triangles. In this particular postulate, we're calling this angle side angle. And this says that if we have two angles and the included side, so if we go back to the last lesson, included meant the side, it meant the word in between. So this is two angles and the side in between them. And if you look at the picture in this problem, you can see the side marked congruent is in between two angles that are also congruent to each other. This is the visual of what side angle is. So in this problem, if we wanted to mark this triangle congruency statement, triangle ABC would be congruent to triangle X, Y, and Z. And if you notice, triangle ABC, angle A has one congruency mark, and in triangle X, Y, Z, X has one congruency mark. So again, make sure that the coordinates match up accordingly between triangles. The next postulate is called angle side. And if you've noticed the pattern that the letters of the postulates determine the location. So in this postulate, we have two angles, but the side is not in between the two congruent angles. So if you have two angles on one side, no matter where the side is, you can prove triangles are congruent. So if you look at the picture, the two angles are congruent are listed on the bottom, and the side that's congruent is listed on the right. Again, so if I wanted to prove the congruency statement or write the congruency statement, angle A is congruent to angle D. It doesn't have a congruency mark. Angle B has two congruency marks, and so does angle E. And C has one congruency mark, and so does angle F. All right, similar to the last lesson, we want to know, we can't prove this true by either of these, but if we had additional information, we could. So based on what's listed here, right, how can we prove this is true? And they tell us that angle ADC is congruent to BCD. So if you look, again, the middle letter is the angle we need. So if you start at A, go to D, and go to C, you have these two congruency marks. So if we wanted angle side angle, we would need another angle and another side listed. Okay, so if we look at this triangle, which I highlighted, we would have a side. Now the side is congruent on the bottom by the reflexive property. They both share the same side. So the other angle we would need is going to be the angle on the right side. The angle on the right side is going to be DCA in the red triangle and CDB in the green. If we were to prove this by angle side, we would need to prove that angle A is congruent to angle B. And if you notice, the side, which is on the bottom, proven by the reflexive property, is not in between the two congruent angles in angle side. In this problem, we want to look at some examples. So now we have 4 ways to prove triangles are congruent. The 2 we learned last lesson and the 2 in this one. So if we look at problem A, we see the top triangle is angle side, and that's actually not one we even talked about in class yet. The bottom one would be a side angle side. Because they're both not the same, this one would be no. Angle B has 2 congruent sides listed, and we know that they have vertical angles that are congruent, and these angles happen to be in between the 2 congruent sides, which is the definition, the criteria for side angle side. If we look at C, we see we have 2 congruent angles and they have a shared side. And that shared side would make this congruent by angle side angle. If we look at D, we notice both triangles have 3 congruent sides each. So this would be an example of side. In this example, we want to prove these 2 triangles are congruent. So based on the given statements, we want to write those down. So angle K is congruent to angle C, and the reason is it's congruent. And we want to mark our statements, or mark our triangles. Angle L is congruent to angle E. And we mark those. So we have two postulates that have two angles. It's either angle side angle or angle angle side. And if we look at the given statement, KL is congruent to CE, and we're going to notice that that side is in between the two angles. So now we have enough information to write the congruency statement and prove it by angle side angle. In example 3, they give us angle A is congruent to angle B, so we mark that in the triangles. Then we find out angle AP is congruent, or side AP is congruent to side BP, so we mark that congruent. So if we're going to prove this congruent using anything right now, we can look and say the two angles in the triangle around angle P, around point P, are congruent because they're vertical. And if you look at the diagrams of the triangles, we see that angle side angle is shown in both triangles. And so therefore we can prove this congruent by angle side angle. And if you've noticed so far in all the problems, congruent sides are either given to us, or they're congruent by the reflexive property, or if they're listed as some type of midpoint. Angles are congruent if they're given, or at this point if they are vertical. So really we're only looking for a few things in these types of problems. We can make them more difficult if we want, but right now it's been a pattern of finding vertical angles and finding reflexive sides.